Welcome back. Day 2, session 2 of Open Networking and Edge Executive Forum, ONIF as we call it. We really appreciate you all joining, and this is a very exciting section today. We have some great speakers and representing, pretty much the top companies that we can sort of think of. And what I would like to highlight again, for those of you who may have just joined, you can ask question and answers. These are live sessions, not pre-recorded. There's a Q&A button on the top. Just send them the question. If you have been with us in the morning, as you know, I was able to at least get 15, 20 questions quickly into the speakers. So, they will answer it in real time, and we really appreciate you all joining. So let's begin the second section with a company that also needs no introduction, Baidu. And we have the chief architect of IoT, Leding Li, who has been a very active contributor to several projects in open source in the Linux Foundation Edge, as well as other umbrellas. And we want to understand what they're thinking from an open source and an edge perspective. So without any further delay, please welcome Leding.
Hello, everyone. I'm very glad to be able to participate in this executive forum today. I'm Leding Li, the Chief Architect of Baidu Cloud IoT. As a member of the RF Edge Technology Steering Committee, I'm very fortunate to be able to participate in the technological innovation of global edge computing. Edge computing has grown rapidly in the past few years, from the early as a data agent service for the IoT to a general purpose computing service covering various application screen nodes and facilities. We can see that with the population of various new computing resources, such as the mobile edge computing, the new kind of content delivery network, the boundary between the edge and the cloud is consistently becoming blurred. We're moving towards an era where computing is ubiquitous and workloads from the edge are going fusion with the cloud. We can see in many real cases, companies collect data in the cloud and train models, and then use these models to perform a real-time data processing at the edge. This means that the edge is becoming combined with the cloud to become a single integrated service. What I want to share with you today is how the Beetle product and the RF Edge connects the edge and the cloud together. So next page, please. Okay, first, let me briefly introduce the Beetle product. Beetle originates from the IntelliEdge product incubated by Baidu in 2017. And then in the next year, we decided to open source it and successfully joined the RF Edge community in 2019. Today, Beetle has grown into an open and vendor-neutral project. As one of the earliest open source projects in exploring edge computing, Beetle has already got a bunch of features. Beetle can now provide a microservice orchestration in various IoT environments and can seamlessly extend cloud applications and data to users' private networks and private network equipment, and provide a containerized application operating environment for all types of equipment. You can visit the project homepage, beetle.io, for more technical information. And next page, please. The Beetle project has set 3 core development goals for itself, corresponding to the applications, the management, and the developers. In terms of applications, Beetle's goal is to bring a standard and open cloud-native environment for all edge screen nodes, so that applications can be freely deployed and run according to the actual needs without adoption and modification. The second goal is to allow equipment to operate automatically under unattended conditions through real-time and through the remote management and configuration, and even can be able to make independent decisions and collaborate with each other when the environment and the data change. The final goal is to provide developers with end-to-end application development tools and services to promote the further innovation development of edge computing. And next page, please. In the past years, Beetle has made great progress. We have released an important 2.0 version, which enable us to move further towards Beetle's ultimate goal. In Beetle 2.0, we have introduced a standard Kubernetes environment for edge devices. Applications can be defined in the form of resources such as pods, service, and deployment, just like what you do in the cloud. Beetle will accept these definitions from the cloud, save it to the local storage, and manipulate local Kubernetes in the local cluster. In fact, all services, including the Beetle system itself, are cloud native. Beetle runs as a Kubernetes service, and we have implemented the self-upgrading with the Kubernetes way in Beetle 2.1. At the same time, we continue to support the Docker and the non-container barrel process models. This for the low-end equipment, and introduce an experimental Windows environment support. Beetle is working hard to continuously expand the range of device support and provide developers with more different choices. Another important feature is that we released the Beetle Cloud. This is a completely open source remote management system. You can use Beetle Cloud's open API to realize the configuration, software upgrade, application deployment, and data collection and synchronization for various edge devices. Beetle Cloud can directly connect with your Kubernetes control plane to obtain resource definitions and send them to Beetle with a secure network channel. With the cooperation between Beetle and Beetle Cloud, the edge and the cloud are connected together. Next page, please. So here is the architecture of Beetle. Beetle Cloud is located in the upper part. You can find that the whole Beetle Cloud itself runs as a service in Kubernetes, and the Beetle Cloud connect to the Kubernetes API server. So by this design, the Beetle Cloud can receive all your Kubernetes configurations and try to send it, synchronize it to your local edge instances. And the Beetle itself is located in the lower part of the picture. And Beetle maintaining the connection with both the Beetle Cloud and its own Kubernetes cluster. So in logical, the local Kubernetes cluster and the cloud Kubernetes cluster can be configured as one. They are integrated by the operation between Beetle and Beetle Cloud. And in this picture, we found that all the original Beetle services are moving inside the Kubernetes environment. In the previous version, the 1.0 of Beetle, we run Beetle as an independent, separated process out of the container system. This process will operate with the Docker system and run all the applications as the container in Docker. But the Beetle itself is controlled out of the container system. So the administrators need to log into your local console and update Beetle itself manually. We found that this is the first step to support the edge system, but this is not our ultimate goal. We want to make this equipment unattended. So in the 2.0, we move all the Beetle system inside the Kubernetes. We define all the Beetle services as pods, as services, and we give the privilege to connect with the local Kubernetes API server with the standard Kubernetes way. And finally, we can upgrade and manipulate all your workloads, both the system services and user applications in the same way. So this is what we do in Beetle 2.0, and we consider this is our most important move to our goals. So next page, please. Sorry, and then next, please. Maybe it's not. It's a later. Yes, this page. Thank you. So to achieve the integration of the local Kubernetes cluster and the remote cloud Kubernetes cluster, there is still an issue to solve. The most critical issue is how to maintain data consistency between the cloud and the edge and an unstable network conditions. Because most of your edge equipment is deployed around the world, there won't be a very stable and high quality cable network connected to a data center. We use the unreliable network, maybe the 4G or even the more lower bandwidth network connections. So there will be data consistency issues when you configure your cloud. The data is not synchronized to the edge side successfully. So they will run in different view of your configurations. That will make data corruption. So we have to solve this issue. This is the shadow CRD technology proposed by Beetle. In this technology, we combine the user-defined resource of Kubernetes with the digital twin of IoT together. The former one, the CRD, guarantees the integration with Kubernetes environment. So all your operations will go to the Kubernetes way, and the later one will get the exactly once QoS requirement through the MQTT protocol and the desire and the report semantics. So let me show how this works. In the picture on the right, show the typical edge cloud synchronization process. First, the Beetle cloud connects to the Kubernetes API server and the cloud, obtains the deployment resource, and pack them into a shadow object we call the desire object, and then sends the desire shadow object to the edge through the MQTT protocol. The MQTT protocol itself includes the capabilities such as the error checking and the network retransmissions, and fulfills the quality of service. By using the MQTT protocol, the desired shadow object will successfully be transmitted to the edge side. The edge side, by receiving the shadow object at the edge side, the Beetle will unpack it and send the original CRD definitions to the local Kubernetes cluster for the deployment. After the deployment is achieved, the new state of which reflects all your configurations of your applications and the data will be collected by Beetle from the local Kubernetes API server and packed again as a shadow object. We call this shadow object as the report. And we send this report shadow object by the MQTT protocol again to the cloud. And in the cloud, the Beetle cloud system will unpack the report shadow object and reflect all the changes from the edge to the cloud. This will solve the data consistency issue through an unstable network. This is the shadow CRD technology of Beetle. And next page, please. So finally, let me introduce the Beetle's roadmap in 2021. The first and the most important is we will continue to work hard to achieve a deeper integration of edge and the cloud together. And ultimately, we'll use a single control plane to manipulate all your workloads. In our think, in the future, all your workloads can be controlled, can be declared, controlled, and observed in a single Kubernetes dashboard. So this is our final goal, and we will make it better in 2021. And how to make this happen? The first an important step is to strengthen the observation and the measurement of edge status. We will send the edge health data and application runtime metrics data to the cloud to provide a better capability for the operations. In addition, we will work with the Agrino community to explore how to use the mobile edge computing by 5G network to implement a better low latency services for new kind of applications, such like the auto driving or the VRs or the cloud gamings. And we'll try to research how to serve a moving application by your mobile phone or by your other mobile devices. This when we move across different base stations of 5G networks. The application should go with the device, go to keep low latency with your applications. So this means the application will be roaming between base stations or roaming with the MEC data centers of 5G networks. This may be, I think this is a very interesting thing, and we will try to explore how to achieve this in this year. At the same time, we'll strengthen the construction of documents and to attract more contributors in interesting Beetle products. And we are going to collaborate with more chipset services, chipset providers, and more infrastructure providers to support not only the x68 chipset, the ARMS chipset, maybe the RISC-V chipset in the future. And we are going to collaborate with more RF Edge communities such as Edge Foundry and Agrino to make more cooperations. Okay, next page, please. Okay, this route will be reflected in our specific detail works. The most important thing is the cooperation with communities. We are working with the Edge Foundry to bring an open source IoT solution to Beetle. So users can define your IoT system in the cloud and test it and deploy it to all your edge devices. And we're trying to work with the Flash community to introduce more industry screeners to accept more industry protocols and data to the edge system and connect them with the new technology like the data processing or the artificial intelligence. I believe that with the joint efforts of the community, edge computing will play an more and more important role in the future. So this is what I want to share today. Thank you.
Excellent. Thank you, Leding.
Thank you.
Yeah, and really, we have seen a lot of great progress in just 1 year. Since the time we chatted, and I think the Beetle has not only gotten a great roadmap, but a lot of collaboration with LF Edge. LF Edge in general has a lot of momentum going into from a unification of frameworks perspective. So thank you very much for your leadership, and thank you for communicating today. Thank you.
Thank you, Arpit.
All right. So we're going to move to the next presentation from the Director of Open Source WeHu at ZTE. Again, company needs no introduction, obviously. And I'm just going to hand it over and hear what you have to say. Take it on.
Hello, everyone. I'm Jeff from ZTE, and in this time, I want to try to introduce my companies working on the open world. Please move to the next slide. Okay. In this picture, I want to try to demonstrate our footprint in the open world, not only the open source community, but also the open standard. As you know, ZTE is a networking equipment provider. Our customer is mainly the network operator and also consumers. And now we expand our business to a lot of vertical industry, like the manufacturer, and also to cooperate with our partners and working with partners to expand our business. In this picture, we can see ZTE mainly working on 3GPP, ITU, ETSI, and IEEE, things like that in the open standard organizations. And also from the 10 years before, ZTE began to move into the open source areas like OpenStack, and also Linux Foundation networking, and also Linux Foundation AI, and also a lot of others. Next slide, please. First, I want to introduce, we have contributed a lot of open source area communities like OpenStack. Since 2013, ZTE began to contribute to the world of cloud infrastructure. In the OpenStack, we continue working until now. And in the chain release, we ranked the 7th in the world. And also we have 8 project leaders and ranked the 2nd place in the election of the OpenStack Victoria release project leaders. And we have 13 core members worked in the communities. Next slide. Since 2014, we worked from ETSI NFV standard and began to cooperate with the carriers on the OPNFV, we began to the planting members, and also contributed on several key projects like Q-tip, Daisy, Faros, Feng test, and Relan. And also we have a board member, TSC member, and 2 cores. And we we get the OVP certifications, like the infrastructure and also open labs. We continue cooperate with the OPNFV in the CNTT last year, and we try to work on the advocate in the future. Next slide. In the SDN field, we are the planting member of the Urban Daylight. We ranked 4th in the history. I think the Urban Daylight is more stable now, and we have 6 PTLs and 21 core members, 1 PSC member in the communities. We have initiated 6 new projects like BS, OFF configure, P4 plugin, telemetry, and DataNet, and outer data stores with our partners in the ODL communities. Next slide. Begin with the 2016, we joined with China Mobile to initiate the network automation project OpenO, and also be a platinum member after OpenO, joined with eCamp. We ranked the third place by 7.37% contribution ratio. And also we have 2 PTS on micro service bus and homeless. We have 21 core members and TSC members. And also we worked with operators on VEPC and VMS, which is verified in China Mobile Lab, and also with China Telecom Lab on VCPE. Next slide, please. Since 1997, we also contribute to the cloud native world. In Kubernetes, we ranked 4th in the world, and also 2nd in China area, and also cooperated with Docker, and also in the cloud native. We worked on the container D and ranked the 2nd place in the China. We are the CNCF Gold member, and also we have several key members in CNCF in Kubernetes. Also, we get the Kubernetes certification for our product, Open Pilot. Next slide, please. Also, we focused on the massive storage areas in Surf project. Now Surf became a Surf Foundation. We are the founding planting member in Surf Foundation, and we have 1 TSC member and 3 core developers in Surf project. And in the release K to M, we ranked third in the world and the first place in the China. We also published some 2 books on surf to promote the surf technology in the China. Next slide. Also, we initiate a project on AI in the LF AI plus State project, plus State foundations. ADLIC is an end-to-end optimizing framework for deep learning. It accelerating deep learning inference process for both cloud and embedded environments. The main components of the ADLIC is a model compiler, which can using different model types, and also we have the inferencing engine, which can increase the speed of the inference process, and also we have a benchmark test module to benchmark, help the application developer to test their module. Also, we cooperate with the ITU on AI and ML in 5G challenge in 2020s. Next slide, please. So what ZT focused on, I think in the open world, we will still continue contributing on the 5G related specifications, and also in the open world, we work on the contributing on the general, efficient, flexible platform and frameworks. And also in 2020, we have joined the RISC-V, and also we support China Mobile to initiate the XGVILA project, which we think is very important to our customer and the end user. In addition, we will continue support advocate and try to get the badge to certify our products in the next year. Please go to next page. In this page, I want to introduce our product on the 5G one-stop 5G private networking, which can enabling in all industry. We have 2 or 3 different kinds of configurations. From left to right is the first one is the dual rack high configuration. It consists of 2 cabinets, one for the network, one for the cloud. In the cloud cabinet, we provide the data middleware and the AI middleware, and also video and edge. It is suitable for big enterprise and headquarters of the end users. In the middle is an integrated cabinet, which integrates the cloud with the network. It's more efficient, and it's suitable for the enterprise branch and some campus. And also we provide the simple configuration, which is a single shelf, and it's most costless. All of this configuration provide you cloud and network convergency, and also the fixed and mobile network, and with full access to different kinds of connections. And also we support multiple computing convergence with different type of computing. Next slide. In this slide, we show in ZTE Common Edge 4 scenario Mac, which provide you the Mac tenants with self-servicing provisioning and provide the operator the ability to unify cloud management. This is a one-stop deployment. And we use the embedded Mac, pre-integrated Mac, and also Cloudify for Mac. And also this one solutions has got the layer 1, 2, 3 award in last year. At the end, please go to the next slide. At the end, I think we can discuss some challenges and opportunities lies before us. Since we know most vertical industries has recognized the power of ICT, especially on 5G, edge, cloud, and AI. This can help them increase their productivity and efficiency. At the same time, but they also feel the threat for the industry disruptions. This can be a challenge and also opportunities. And also for the COVID-19 pandemic, we think it's already changed our life and work, maybe forever. Working from home has been verified valid, both in our company and also in most other industries. And also traveling has been limited until vaccine were used worldwide. I think this will take a long time. I'm looking forward we can meet in person in the future, in the very near future. But in my own works, I found a lot of product people don't think open source could make profit for them. How do you deal with them on this? How do you persuade them to trust open source and make them believe the open source? Thank you.
Excellent. Very good, very good. First of all, I have to congratulate you that, all the various projects and various umbrellas that you have been participating, collaborating, and leading in a lot of instances with your team of technical people and yourself. So thank you very much for doing that. I think the overall business model on open source is fairly mature now. I think you heard from Rakuten and others, as well as you can see from the partnership that the carriers have provided in terms of going through the vendors versus just doing it themselves, right? So I think that the things have settled down quite well. So very good. Thank you very much. Thank you for doing this. Okay.
Thank you, Arpit. Thank you, everyone.
Very good. Excellent. And now for the final presentation, a very important one, because I do believe that, what China Mobile says, the world has to listen. It's the largest carrier, lots of research going on. lots of very, very smart people, and we have one of them to speak to us today. And so without any further delay, I do want to welcome Dr. Feng, Chief Scientist and General Manager of China Mobile Research. And we will love to understand where things are, where you see things going, what we should all be looking for. So Dr. Feng, take it away.
Hello. This will be interesting. I don't see you, but you can see me. We'll see how this will work. But it's very happy and to see Arpit, to know we have about over 1,000 engineers and practitioners join us. Today, I will not only talk about China Mobile. I just have one slide. So pretty much it's how we see the entire industry, how that goes. So move on to continue to talk about the topic here is network intelligence. And I see not China Mobile, probably across the entire industry, not just our industry, other industries are increasing their investment intelligence, how to intelligify the internal management, internal operation across various industries. So today I will cover a few aspects, so I'll limit myself to 15 minutes. What's the motivation? Talk about what are the main drivers, what are the typical approaches companies are taking to making the business, making the operation intelligent. Second is how our observation. And then I will move on to share a survey conducted by UAG in this community, see how the community says about the stage of their network intelligence, and I will give a few suggestions. Next. So this one is the motivation. Since I have lots of small fonts, I have to open up for my own version. So there's a couple motivators I'm thinking are driving us to transform towards intelligent network. And the lower layer is the network itself. It's before we have the wireless, so we have the core, we have the transmission network. Now the whole structure is changed. You have a basic infrastructure and that layer, and then you have the VNF, you have CNF, then you have the operation layer, then we have the business and service layer. For us and how we see the industry, I'm thinking that operation intelligence now is the core. If we read all the reports from the agencies and a couple SDOs, we can see this trend where and this current stage where the intelligence efforts goes to. It's pretty much a focus on the middle layer, the operation layer. So it promotes the transformation to further improve the efficiency and then lower the costs. And also, we have the scale of the network and the data volume network is increasing dramatically. How we can operate that network and at the same time maintain lower costs. Then we see the trend is taking that layer as the core, baseline layer, then synchronize the efforts with the lower layer. The network itself become more intelligent, also the service and the business layer. For the top layer, we see a trend is for the typical applications of 5G, people are proposing are deploying and also the typical applications of 5G, the AI, and larger scale. Over 85% are overlap. So basically, before we plan, we build, we optimize our network for voice over IP, for data, for talking over phone. Now it's the I'm thinking in the applications with intelligence as a key feature are the probably one of the biggest services we have to support well. So as a key feature of intelligent applications, they have to be flexible, has to be closed loop maintenance. So that will require network to have the same feature. So our current network is not as flexible as the applications hope we are. So that's the service layer. So we can hope one day we can users give their intent. We can control our network to serve that intent to improve the customer experience. For the second, the operation layer, I can see the trend in the standard organizations in open source, our open source community, and the other open source community, and also in the research literature. Lots of great work are coming out on this layer, how we can further control the costs, improve the efficiency. And in terms of network, the lower layer, there are a couple of things. One is for the network elements, each network element has their key functions. And some of those functions have been changed because of the intelligence technologies that we have as of today. And then the other one is the interface between the network elements. Since we have this technology, the way the interfaces between the network elements are changing. So next slide. So this one probably looks quite complicated. On the left side is the TM5 forum. They show how we need a few closed loop in order to keep our operation intelligent. So here you see there are 3 loops that we need to have. Once we have a business intent, then translate to a service intent, then translate to network intent, and translate to resource intent and the data. And then come back, we need to keep a promise so we can provide that service with the high quality, that's the KPI, and the SLA feedback, and the customer experience assurance. So that's the big loop. And in this whole circle, you see there is a horizontal circle, which is the business automatic closed loop, and the service automatic closed loop, and the resource control closed loop. So that's pretty much the one of the key feature of artificial intelligence applications is you cannot have a product and without touch it for long. It has to be in a loop, and then the model has to be upgraded, and the data has to be continually processed. So it's I call it's something itself has it's a life being versus a product, the traditional product, which you buy a cup, the cup stays on your table. So on the right side, just open up how different parts are connected. So now we can see for the SDOs, they have laid up lots of efforts. Almost every single our standard organization has put in lots of work in various forms to push the network to be intelligent. So in this graph, you see you have the pink one is the local AI. So for the wireless domain, the RAN, transmission network, and the core network, and each domain, there is specific efforts in that domain. Here I show it as a local AI. But I'm proposing here is if we hope we can provide the service, which as intelligent as the business hope we can support. Now we need also a general intelligence layer, that's the right side. so which can cross this from the top all the way to the bottom. So we need to have that view. So in order to have the overall optimization target versus we optimize in each specific domain, but we don't have the overall picture. That's will make the whole network fall into a local optimum versus a end-to-end intelligence operation. So next slide. Next one, please. This next slide just talk about, did I go back to the open source? Yeah, thank you. So this is you can see the pictures are quite similar to the one before, just showing where our community, the software, the projects that we're putting, where we see them on the overall picture. We see the ONAP, it's especially just take ONAP as example. It's very key components to assure the business intelligence and the service intelligence layer. So we have Acumen, so we have ONAP, we have PNDA. I hope we can increase that efforts in that layer, because the operation intelligence, I'm thinking at current stage, will be the driver for the top layer and the lower layer intelligence. And we see now a trend is ONAP also closely work with the Open RAN, work with the RIC to help configure and orchestrate intelligently in that specific domain. For the infrastructure layer, we see there are a couple of standards come out for Fed AI, which is quite hot. It's I think it's that standard was passed in IEEE last year, 2019. It basically redefines how machine learning can learn a model without the risk of data security. This is next one. Go to the survey, EUAG. Next slides, please. Okay, sorry, I have a cold today. So this is initiated, proposed by China Mobile, was conducted by LF and UAG. So far we got 65 feedbacks from 20 telecom operators, more than 10 digital service providers, and over 30 vendors. So we can quickly go through the data. So overall, looks like we ask that questions where you see we are in terms of intelligence level. We can see most companies think they're at L1 and L2. So it's level 1 or level 2. So we are at the preliminary stage, and see where the applications and the research. So that's also at the pilot stage, which is the work has to hand. So see that topic as network intelligence has become quite a hot topic now in the research community. But I'm thinking as the industry, we're starting doing that. For the R&D, can see how the intelligence, the development and the deployment, who should be the one to doing the work, how the operators see this picture. So we can, for the proof of concept and pilot, we can see the percentile on the right side and the first picture. And the second pie graph, it shows the percentage of self-development and rely on partners, or rely on big partners and the small partners. So here have a couple conclusions, and for now from the survey, so more than 50 operators think they are doing the intelligence platform on their own, just self-developed, and more than 2 two-thirds of the operators to think they are also doing their own applications too. Just to share, well, this data we have run the analysis, I'm thinking some of the conclusions align with our observations, some are not. So we will continue to have new ways to know where overall we are in terms of the whole industry. Since the time is almost, I use up all my 50 minutes, I will quickly go through the suggestions. So I suggest for the 3 slides, the first one is, we hope we can carry out a top level design for platform function and the management architecture. So how we can build the overall and the overall general intelligence across the layers on the right side, and to build an intelligent and open industry cooperation platform. And we also need to work closely with SDOs and also other cross organizations, also work with the AI companies. And for LFN work, well, inside our community, we hope we can take operation intelligence as the core, and then we take that as the driver to drive the intelligence transformation and the service layer, and also the network element layer. So we draw these 2 graphs, and then one is the service intelligence and the other one is the lower layer. Hopefully that's our just suggestion. Maybe it's right, maybe it's not, to see the path. The last one is, I'm thinking is, in order to make our network intelligent, it has to be flexible. To be flexible, it's not enough we have certain amount of network operation knowledge, we have certain set of data. We also need an environment which can be a resembled or experimental place, and developers and algorithm researchers, they all can put in their model, see how that works. So without a simulation environment, I'm thinking it's pretty hard. For me, the intelligence come from, well, the intelligence of computer come from 3 resources. One is data, one is knowledge, and the other one is the environment. So the model, the AI algorithm, the model, the product has to explore the real environment and to improve the self on the fly, and to truly get intelligent, versus we have the offline intelligence, but once we put in the real network, it's always a big question mark. So they are free of put that into network and make it a larger scale. With that, I finish my slides. Arpit.
All right. Excellent. Thank you, Dr. Feng. So first of all, I was just so engrossed in what you were saying that I just didn't realize that, we're there. So a couple of observations, and there's obviously a couple of questions that I want you to address first. So the one of the questions is saying China Mobile was largely responsible for the CRAN technology, which triggered the entire 5G movement. What are we going to do, and how is China Mobile, thinking about once again taking a leadership position and continuing in the future?
Yeah, thank you for the question. Well, CRAN basically is a great invention. It changed the overall architecture of RAN. So I'm thinking for now, probably I'm talking about the intelligence layer, we'll continue our overall efforts in CRAN. I'm thinking is we hope in China Mobile is invests a lot in the network intelligence, and the same thing for the RAN. So we hope that the CRAN give us more opportunities so we can put the intelligence in. For example, you separate DU and CU, and between the DU and CU and the AAU, so how we can match the resources So you need something in the middle, which is intelligent enough, who can sense the network, sense the dynamic, and automatically intelligently adjust the mapping. So that's the CRM truly gave the architecture, give a way we can put intelligence in.
Okay, excellent. I think in general, your overview of how standards and open source and network intelligence and all the layers couple, they all looked very cool. And I think with your leadership and with your entire company behind open source and standards, I think we really appreciate the support that you all have given. I also want to publicly thank you for being the chair of the governing board of LF Networking all of last year. And we're looking forward to some even more cool things from China Mobile and your influence globally. So really appreciate you taking the time. And thank you very much.
Thank you. I'm so happy to work with the community. We have to work together, change the world, make it better. Thank
There you go.
Arpit.
There you go. Thank you. Excellent. This ends our second day of ONIF. We will see you tomorrow morning at 7 a.m. Pacific. It'll be a little late in Asia, but do join in. We have some very exciting presenters on the EU front, and look forward to all the recordings that come out. But thank you again for joining. Good night, good morning, good afternoon.